We are continuing our lesson on power of a power, and our question number 2 says simplify using exponent laws. So these questions all have coefficients in front of them, which is a little bit different. So you can tell something is a coefficient instead of a base because it does not have a visible exponent, and it's usually, well, it will be in front of a variable. So it'll be in front of a letter that has an exponent on it. So our first one here, we have 5x to the power of 2 in a bracket to the power of 3. And we did just learn in our investigation in the previous video that when you have one base with 2 or more exponents, you leave the base the same and you multiply those exponents together. So if I have 5x to the power of 2 to the power of 3, we're going to try to use that exponent law. But I have a coefficient, and we haven't talked about what to do with the coefficient yet. So that power of 3 is on that entire bracket. Now inside the bracket I have 5x squared, and it's just one term, and there's really nothing to do inside of that bracket. But that power of 3 belongs to everything inside that bracket, which means it belongs to the 5. So 5 is to the power of 3, and it also belongs to the x squared. So x squared is also to the power of 3. It's kind of like doing distribution that we learned way back when we were doing algebra, that everybody gets a power of 3. It belongs to all of the terms in the bracket. So I am, for right now, just going to leave 5 to the power of 3 as is. X to the power of 2 to the power of 3. I have one base and 2 exponents, so I multiply those 2 exponents together. So I get x to the power of 6. So I could leave this as 5 to the 3, x to the 6. Or because the 5 is a number, I could work that out. I would use my calculator to figure out what 5 to the power of 3 is. So you either do 5 times 5 times 5, or if you have an exponent button, you can do 5 to the power of 3, which is 125. So this is 125 x to the power of 6. All right, we're going to try another one. So I have 8 x to the 6, y to the 9, and inside a bracket to the power of 2. So when I'm thinking about this question, I do notice that there is a bracket. So I would try to simplify the bracket first. I notice 8x to the 6, y to the 9. I don't have any multiplication I can do. I don't have any division that I can do. There isn't really anything for me to do inside the bracket. So I am going to move on to the exponent, which is that exponent of 2. So everything inside this bracket gets that power of 2 because that power of 2 is on the bracket. So that means that 8 gets the power of 2, x to the 6 gets the power of 2, and y to the 9 gets the power of 2. So I'm going to leave the 8 squared for a minute. X to the power of 6 to the power of 2, if they have one base and more than one exponent, you multiply your exponents together. So 6 times 2 is 12, so that is x to the power of 12. And then y to the 9 to the 2, I leave the base the same, and I'm going to multiply those exponents. 9 times 2 is 18. So I have 8 to the power of 2, x to the power of 12, y to the power of 18. And I could just leave it like that. That's not a problem. I have simplified using exponent laws, but I think I am going to work out what 8 squared is. 8 squared, 8 times 8, is 64, x to the 12, y to the power of 18. Now we have one last question. We have 100 x to the 20 divided by 4 x to the power of 5 in a bracket all to the power of 4. So when I'm thinking about order of operations or BEDMAS, we start with brackets. And I do have a set of brackets right here. Now, is there anything to do inside that bracket? Why, yes, there is. There is some division. So when I divide, if they're exponents, I leave the base the same and I subtract their exponents. But if they're coefficients, so numbers in front of the variables, I just divide them. So 100 divided by 4 is 25. And then x to the power of 20 divided by x to the power of 5, they have the same base, so I leave it as x. and then I subtract the exponents. It's tempting to divide them. I sometimes forget to do it, but you really need to try to be very aware and make sure that you're subtracting. So 20 take away 5 is x to the power of 15. And then this is still in a bracket. If you want to make it square, that's okay. And that's to the power of 4. So now that I have simplified what was in the bracket, I can move on to exponents, and I can deal with that exponent of 4. So my exponent of 4 here belongs to everything inside the bracket. So it belongs to the 25. So I have 25 to the power of 4. And it belongs to the x to the 15. So I get x to the power of 15 to the power of 4. I am just going to leave that 25 for a minute. 25 to the power of 4. And then with the x, it's one base with 2 exponents. So I'm going to multiply those together. 15 times 4 is 60. So I have 25 to the power of 4, x to the power of 60. You could leave it like that, but I think I'm going to work out what 25 to the power of 4 is, and that's not one that I know off the top of my head. So you can multiply 25 by itself 4 times, or if you have a scientific calculator, you can work out 25 to the power of 4. So I got 390,625 x to the power of 60. And that's what you need to know about doing power of a power.